In this lesson, we're going to look at angles of triangles. And we're going to do the triangle sum theorem, which we'll see in a few minutes, and then the exterior angle theorem, which is really powerful. And I guess we don't practice it enough, but it's really neat, the exterior angle theorem. Before we do any of that, I just want to say that in geometry, we're always looking for connections and relationships that reveal information beyond what is given. I've written that down. I think I've alluded to it before. But the neat thing is, a lot of times you can find the measure of something that you can't measure because you know relationships of things that you can measure to the thing that you can't measure. And so you can know that additional piece. For example, if you meet your uncle's daughter or your uncle's son, then that's your cousin. So you know it's your uncle, you know it's his child, but the connections of all that means it's your cousin. It's just kind of neat how those kind of things work, but we apply them in our world an awful lot in geometry. The triangle sum theorem says that the sum of all three angles is 180. We actually used that in the previous lesson to do a problem, even though we hadn't discussed it because we've discussed it before. So we're going to use that. In this problem, we have this softball that's being thrown round and round in these players. I've told you before, they're trying to make it relevant, okay? I put this little thing here that says work with what you know. I'm just put that there because sometimes you don't know everything, but you start with what you do know and you work toward what you don't know. So they want us to find the measure of all the numbered angles, and we have 1, 2, 3 of them. So I'm going to begin by looking at this triangle where angle 1 is. This triangle, I happen to know, is a 43 degree angle, a 74 degree angle, and an unknown. So just to be clear on that, the 43 and the 74, when you add those together, is 117. Since it's 180 in all, how much is left? And you do a little subtraction, you find out that this is 63. If angle 1, I'll just measure angle 1 equals 63. If angle 1 is 63, then what is angle 2? Because those are vertical angles, it's also 63. So the measure of angle 2 equals 63. Finally, we're left to try to find out the measure of angle 3. Let's look at this triangle and let's realize that we know a 63 degree angle, a 79 degree angle, and an unknown angle known as angle 3. So put those together, add, and get 142. So how much is left for angle 3? Well, you got 180 in all. Subtract the 142, you get 38, I believe. So the measure of angle 3 is 38 degrees. I should put degrees on all those, I guess. And we got it. The next piece says find the measure of angle 3. Up here's angle 3. Just going to make a little note of that. Find the measure of angle 3. Unfortunately, we're going to have to find the measure of angle 1 and 2 to get the 3 because of the way this drawing is done. In this, I'll call this, I'll just point at it. This triangle here, I only know one angle, so I can't work with that. But here I know two angles. So I can do what I did previously, and I can say, well, the 38 and the 67, when I add those together, that's 15, that's 105. So these two here together makes 105. So how much is left for angle 1? How much is left? It's 105 in all, so that means this one's 75, because that with the 105 make 180. If this is 75, then this is 75. And then we can use that to try to come back here and find the measure of angle 1 by looking at the red triangle. In the red triangle, you know two angles. I think that's right. Sometimes you look at it so long, you question yourself. So that's a 7, and that's 7 minus 2 is 5, 57. I believe it's 57 is answer C. Good. Okay, exterior angle theorem. The exterior angle theorem says, you can read it right here, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two interior angles. So let me just give you a couple of ideas and thoughts here. So let's pretend this is 130, and let's pretend that this is 20. May or may not be the truth, but let's pretend it is. If that's true, then this is 150, because that's what that tells us right there. Angle 1 is the sum of the two, what's these words? Remote interior angles. First of all, there are 3 interior angles. It's a triangle. That's what happens. You got 3 interior angles. This one is not considered remote. Right here, it's not considered remote because it's touching the exterior angle. These two over here are away from or remote to this exterior angle here. So that's how that works. Let me give you one little piece of flavor here just so you know. So if this is 130 and this is 20, then that's 150, right? The two of them together make 150. So that's 30. And even if you didn't know that connection with 150, what do these two have to do? They're a linear pair. They have to equal 180. So if I knew that's 30, then I would know that's 150. So it's kind of two ways of saying the same thing. So we need to get this remote interior angle stuff kind of locked into our brains. So let's look at angle 1, which is this one. Angle 1. And I say, name the two remote interior angles. Well, when you're looking at angle 1, remote interiors are 5 and 6. So angle 5 and angle 6. For angle 2, you're looking at this angle. Who's remote interior to angle 2? 7 and 6. Those are the ones that do not touch angle 2, right? And then finally, angle 3, which is this exterior angle here. Who are the remote interiors? 5 and 7. So you need to be able to kind of hunt those things down, break those things out, pay attention to the details, because it's going to be important to a ton of problems that we do along the way here. Now, notice what I did here. I flipped that picture. Same picture, I just flipped where the exterior angles are created. You see it? Okay, so the measure of angle 1, angle 1 is here. And we want to know the two remote interiors. So for angle 1, the remote interiors are 5 and 6. Oops, didn't make my angle mark. For angle 2, which is here, the remote interiors are 6 and 7. And for angle 3, which is here, the remote interiors, because 6 touches it, right? You see 6 touches it. 6 not remote. It touches it. So it's 5 and 7. So it's just kind of terminology and discussion, pieces of parts. Well, let's look at this one. It says find the measure of angle FLW. FLW happens to be that exterior angle. In this case, they tell us that this exterior angle is 2x minus 48. That has to be equal to the remote interiors, which I hope you see is x and 32 as far as measures go. So I'm going to take the x across by subtraction, take the 48 across by addition, and x is 80. Is that what they asked me to find? No, it wasn't. They asked me to find this angle. Now, it turns out that's 80, but that's not what they asked me to find. So if I put 80 in there, I get 160 minus the 48. What is 160 minus 48? I believe it's 112. And that is your answer. 112. Yes. A piece of quilt fabric is in the shape of a right triangle. They've got the right triangle labeled down here at the bottom. Find the measure of angle ACD. That happens to be this angle here, this exterior angle. This exterior angle has to be the sum of the two remote interiors. In other words, the exterior angle, which has a measure of 3x minus 10, has to be equal to the 90 plus x, or the x plus 90, whichever way you want to do it. So I'm going to move the 10 over there, I'm going to move the x over here, subtract the x, subtract the 10, x is 40. Is that what they asked me to find? Because that's one of the answers. No. They asked me to find the measure of this angle. We said that from the beginning. So when I put 40 in there, I get 120 plus 10 is 130, making the answer D. And the funny thing is, the people who wrote this material fell for their own trick. Ha ha. All right, the triangle angle sum corollaries. If you've got, and this, I'm just going to talk about what this says. If you've got a right triangle, and that's what this is, a right triangle, since they all got to add up to 180, if this one here is 90, guess what these two have to add up to? 90. And that's exactly what this is. The acute angles of a right triangle are complementary. They add up to 90. It just makes logical sense. It just does. And another one is there can be at most one right angle and at most one obtuse angle. Because if you had two right angles would be 180. How much is the third angle? Because it can only be 180 total. So that didn't make any sense. And if it's obtuse, then they're both more than 90. So more than 90 plus more than 90 is already more than 180. And that's just not possible. So that's why those things are just like, well, duh, that. So we got this really big problem here, or really big picture. It says find the measure of each numbered angle. So I've just blown it up for us. Make life a little simpler. Each numbered angle. That's what we're trying to do. Sometimes it's hard to know where to start in these. I'll admit that. But I'm just going to start where I'm seeing, and you can start where you see. But I see that those two have a total of 104. So that means this is 76. Because in this triangle, they've got to add up to 180. So if the two here make 104, that leaves 76 for this, which means this is 76, and that's one of my numbered angles. Yay. And it also means that this is 104 a couple of ways. It's 104 because it's a linear pair. They are supplementary. It's also 104 because it's going to be the total of the two remote interiors, or the sum of the two remote interiors. So that's great. So if that's 104, then that's 104. I may or may not need to know that, but I do know it. I do know it. And actually, I think I do need to know it. Let's carry on. So you might see that this angle here and this angle here has a total of 138. So that means this one up here is 42. Which is nice because this 90 plus this 42 plus this 48 better equal 180 because that's a line right there, and that's what that would have to be. So, carrying on. I notice that this is 34. I noticed that. But this whole thing here is 90. Which means this piece here is 56. Because you got to add up to 90. That's particularly helpful because these two then add up to 132, leaving me with 48 for this one because I've got to have 180 out of the whole thing. It's a triangle. The last thing I see that we have not dealt with is angle 5 up there. And angle 5, we know this is 90, we know this is 41, so that's 131, leaving 49 for that. So they go through this big long dance, but you see, if you've been taking notes, they got the same answer values we got. So this last one asks us to find the measure of angle 3. So that's all we're supposed to do, or all we're required to do. Of course, as I said before, sometimes you got to do other stuff to get there. So, and a lot of times I like to do all of them because I never know what they're going to ask me for, and I like to practice. But these two here are going to be 130, making this 50 and this 50. Since these are a linear pair, they got to add up to 180, and this one outside is 135, then that leaves this inside to be 45. Then, because these two here together are 95, this one up here is 85. And that was the question, was what was the measure of angle 3? 85. That's what we said, right? Yep, 85.